So what I'd like to do now is pop this into a digital asset. So the bits I'm going to put in the asset is this bit for the moment. Let's just separate that down a little. Let me just add a null at the end here. I'm just going to call this wall out for now. Let me just save that. So in order to do that, what I like to do actually is colour these input nodes green and these output ones red. Just my little thing often. And what I'm going to do is select all the nodes that I want in my asset first. Now before you make a digital asset, you need to make a subnet, and that's this little cardboard box icon here, or Shift C. So if you click on that, it takes a second or two, it makes a little subnet work. Now this isn't actually a digital asset yet, this is just bubbled down our stuff internally like this. But you're going to make an asset of it in a minute. So I'm going to call, these needs to have unique names because you can't obviously have the same name as existing tools in Houdini. So I'm going to call this SP Wall Maker 2. There we go. And this first input, let's call this geo in. Or let's call it brick in. So it's our brick geometry. And what I'm going to do actually is add a feature in a minute so we can cut holes and windows and doors. So I'm actually going to make an input for that now and call this cutter in as well, because we want that a bit later. We can edit this in the asset, I'll show you where. So now this is ready to go, we can turn this into an asset. So there's a couple of places you can do that. You can go to the asset menu here and you can do a new asset from selection. Or what I like to do is just go right click and go digital asset, create new. Either way, it brings up the same window here. So here's the name of the asset we have. Here's the type of menu. You can give other authors and bits and pieces here, and it's going to save it to either a directory that you specify, or here it's actually going to save it to my documents. In my documents Houdini 19.5, there'll be an OTLs folder. It'll save it there. So once we're all happy with this, we can hit create. And it then brings up this little window for us. Now if you go to input output, this is where we labeled the inputs. At the moment we've only got one. Because we didn't have the other one connected, it's ignored that for us. And you'll see if I hold my cursor over here, you'll see it actually says brick in. It was the label we put. And there's the name of my asset. Now if we delete that, actually it's absolutely fine. If you hit tab and go to digital assets, you'll see we have it here. So SP Wallmaker. There it is. And we're back in business again. You know, because remember, digital assets aren't saved in the scene here. They're actually saved independently on disk. Now we want to edit this a little bit. So what I want to do is right click. If you go inside, actually, you'll see your network's locked. If you want to edit it, you can right click and do allow editing of contents. And now we've got a unique instance here in Houdini, and it's not connected to the one on disk anymore. So now I can add and edit and do more features to this for them to add more features and edit and do whatever I want. So the first thing I want to do actually is just promote some of these attributes up to this level. So to do that, you right click on the asset here and bring up the type properties. And that brings up this type properties window. This is, and you can go to parameters, and this is where you edit the interface. You don't do it from the gear icon. That's not the place to do it. You can also go to asset and go to edit asset properties and choose your asset here. That will also bring up the same window. So I'm going to go in here. Now I said I wanted to give people control over the length of the wall. That's this one here. So the easy thing to do is right click where it says length and go to export parameter to type properties. Remember, that's the name of this window. It appears here. So we'll call this wall length. And then this is the human readable bit, so we can make that a bit easier to read. Wall length. Let's hit apply. And it will use whatever numbers here as the preset for us. The other thing we want to do is promote the wall height. That was on here. That's this iterations. So again, you can right click, say export type properties, or use Alt to middle mouse button if you want. There we go. So this will be wall height. And then last but not least, we had the randomness, didn't we? Which was here on the chain stop. So there, that was my own little one here, seed 2. So Alt middle mouse button, we'll pop it here, and we'll call this randomize. There we go, randomize. Let's hit apply, accept, and if we come up one, we now have these 3 little buttons here. So that now we can adjust the wall length, the wall height. Oh, back to my 44, and then we can adjust the randomize just to make it look different. That's all very good. Actually, if I'm going to right click and bring up the type properties again, I'm actually going to click on folder and this little arrow to bring a folder over. We can select these 3 with shift, or control's probably better, and you can drag and drop them in. Let's rename the folder to wall. Hit apply, and you'll see the folder gives us a tab, which just lays this out a little bit nicer. So if you hit tab now, go to digital asset and bring a new one in, you'll see your interface is there. Every time you save in this type properties window, it's overriding this guy. This is where your asset lives on disk. And then we're bringing in that instance back into Houdini. Excellent. Let's dive inside and let's add some more features. In fact, before I dive inside, let's create something. I want to cut a door and some windows out of this. So let's create some shapes to do that with. So what I want to do first of all is create a line, and what I'm going to do is get that line to line itself up to this wall. So let's create a line to lay out our bricks and our bits with. So I'm going to create a line node here. So let me template the asset and display the line here. And again, I want it to go across in the X, so let's type 100. And we want to control the length here so we can make it as long as we like. And you'll see it's going from the origin. So here we can use the match size node to good effect. So let me just bring in another copy of the match size. We'll plug our curve in, which we can see here. And now I'm going to plug the wall as the second input. And what you'll see, it uses the bounding box of the wall now, rather than the object, to reposition our line. And it's made it go to the center, the center, and the center. And look, we can offset that here, should we so wish. I'm going to grab the line here. We can change the width. This will be our spacing. Now, I only want 3 points on here. Oh, let me just stow that back. I only want 3 points on my line, 0, 1, 2, because what I'm going to do is I'm going to copy 3 boxes. The 2 outer ones are going to become my windows, and the middle one will become my door. And by doing it this way, I can change the spacing and know they're always sitting in the middle of the wall here. So kind of building it in a procedural manner, even though I'm not putting it into an asset there, which is fine. So what I want to do now is create my window and my door geometries here. So let's create 2 boxes. So let's create a box number 1. So here, box number 1, let's call this window. And let's template that. So I'm going to make this maybe 1 by 1.2, maybe leave it at that. Yeah, let's leave the center there. And let's make a copy of this. Let's call this door. We'll fix the door in a moment. So again, let's leave this as 1 in width and maybe a bit thinner, 0.8 or something, 0.7. Actually, that's this depth there. The depth doesn't really matter too much, but that's fine. So what I'm going to do is let's just create a match size node after each of these, just to make sure they're centered. Their centers are at the center of the world for when we copy them in a minute. So let me just make a copy of that one as well. So this will just center them around the origin. So there they were potentially offset. I mean, they're not in this case, but that's just to make sure it's more robust. And then I want to give them their own name attribute so we can distinguish them later. So here we're going to call this one window, and because they're only one piece of geometry, it's easy to use a name attribute. Let's call this one door. So if we look on the spreadsheet, they have a primitive attribute called, so all the primitives are called door, and all of these primitives are called window. So you know the difference between them. Now I'm also going to merge these together. So we have our 3 boxes lined up. Now I'm going to create a copy to points. So I'm going to copy this to those 3 points, and what you'll see, actually I've copied a cluster of each of these boxes to each of those. That's not what I want to do. What I want to do is copy the window, a window, a door, and another window. In fact, let's make the door a little bit longer so we can tell the difference. There we go. So it's not quite working as we want. So we could use a nice little feature of this copy to points node to do that. And what we're going to use is we're going to use what's called the variant workflow. So basically, if we create an attribute on the points, we can tell which copy or which object to put in there. So the idea is you give each one of these an index, like a 0 or a 1. So I'll give this one a 0, this one a 1, and then I'll give the 3 points here the same number. So this will have 0, 1, and maybe 0 again, and it will copy the right geometry. So let's do that. So I'm going to make a connectivity node again. Let's just do it quickly this way. And let's make an attribute here called variant this time. And it's just that integer thing. So if we look, you'll see we now have a variant point attribute. So 0 for the first block and 1 for the next block. So this is the window, this is the door. So this has got 0, this has all got 1 based on its connectivity. So on here, what we want to do is create an attribute that's 0, 1, 0, and then it will copy over the correct piece of geometry. So to do that, I'm just going to create an attribute wrangle. So an attribute wrangle. And if I look at my spreadsheet, we don't have an attribute yet. So I'm going to create my attribute variant, i@variant equals, and then we'll do @ptnum. And remember, we can do mod 2, which will loop between 0, 1, and 0. There we go, mod 2. So all the odd numbers will get a 0, and all the even numbers will get a 0, and the odd numbers will get a 1. So there you go, 0, 1, 2. Now, since my window is 0, it's going to copy a window here. It will copy the door there, and it will copy the window there. So we'll get window, door, window. So for 3 things, this works. If you've got obviously more than 3, you'd want to manage this in a slightly different way. Now, if we look, we're still getting our clusters, but if we tell this guy, the copy to points, to use this attribute to make the copies. Now, we didn't call it name, we called it variant. There we go. So now where it finds 0 here, it's going to copy the index of 0 based on this attribute, and then 1, copy the 1, and then 0. So now we get our window, our door, and our window copied in, which is kind of cool. So the next thing I want to do actually is if we just template this, or rather let's template the wall. Why is it shading a bit weird, but never mind. Let's template the wall and let's display these boxes. So here with the line, or rather with the match size, I can play with this offset and I can move the windows up and down. I can, with the line here, I can spread the windows out further and closer depending on where I want to put them. So I'm actually going to put, let's put 3.5 in. So quite close to the door there. And we can adjust the height, which is quite nice. So I have them around about the center there. And we're going to use these as a Boolean to cut the holes out in a minute. What else can we do? So yeah, let's color this one yellow so we know what we're controlling there. And the match size, let's also color that yellow so we know what we're controlling here. Let's just do Shift L to tidy these things up a little bit. Let's bring this over here a little. So in order to understand what's happening in networks, what I'm going to do actually is just bring this over here. Just make a net box for it so it's easy to know what's going on in here. Let's call this cutter geo. And I'm going to color that, a nice sort of purple color. So we know we've got creating the cutter geo there. And then here we're, there's my net box. So here we're simplify asset. I don't know if I spelled that right. Let's give that a brown color. And then this is my digital asset itself. So this would be make wall in this bit, if anything. So here would be, let's make that a little bigger. Make wall. We've got digital asset doing that for us. There we go. So now it's easy to know what each section of my network is doing. So we're not quite finished. I am templating that. That's good. So let's have not quite finished down here. So let's just finish this off a little. Now what's interesting, because we made the copies, if we look in the spreadsheet and look in our name attribute, you'll notice it's still calling it just window and door, which is not quite what we want. We want to rename these in a slightly better way. So what I'm going to do is I'm going to add a split node. So split node will allow us to split up the geometry, and we not only use groups, we can also use the name attributes. So let's split out the windows. So in fact, let's split out the door. Let's deal with the door first. There we go. So we've got the door here. So first thing I want to do is to make sure that it sits on the floor. So let's create a match size node. And we'll set the justify to min. So now it just sits on the floor. So now what you can do is go back to the door height here, and you can offset that to what you want up here. So let's just color that node yellow so we know we're adjusting the door height. So there we go. So here we're just making sure it sits on the floor. And there you go, it's a little bit taller than the, let's put that back to 1, 2, 1.2. I want it about there, just slightly higher than the thingies there. And then what I'm going to do is I'm going to use an UV unwrap. You'll see why in a minute. So let's put that in first here. So this will just unwrap the box into 6, which is it'll reproject it if we look at the UV view into 6 planes, which is handy for a box. I'm also going to split off my windows here and create UVs for those too. Now I'm going to add a transform node here just so we could maybe offset the windows if we want. Now you'll notice they're not scaling from the center. That's because if I hit enter, the pivot's at the bottom here. So there's a nice little lifty expression you can type here. So if you put $CEX and then $CEY and $CEZ, these are local variables. Oh, hang on, we've got to do them in each one. $CEY, and then in this one, $CEZ. So this only works on the transform node, but this brings in the centroid of the X, Y, and the Z of the object. You'll see now my pivot's in the center. So now I can scale the windows a bit more predictably. Let's color that one yellow so we know we're doing that. So we can adjust the height and the width of the windows if we want to independently. And you could do that here as well. Mind you, it might be better to do it from up there as well, but it doesn't really matter. Excellent. So let's oh yeah, and what I want to do here is, if we look, our that's the door. If we look over here, all of it's called the window. They're actually separate windows now. So I want window 0 and window 1. So what I'm actually going to do is do an attribute delete. So then we'll delete that name attribute, and then we'll do a connectivity and remake it again. So remember, this is a primitive attribute called name. It wants to be a string, and we want to call this window. So the difference is now it's going to call it window 0 and window 1. Window 0 and window 1. So now we can access these independently of each other, which is always very handy. Last but not least, we want to merge. And we have our cutter ready. So let me just pop these in the net box. Just give them a wiggle and they'll come in. Let's pop a null in there. Call this cutter out. Make that red. There we go. So we have our cutter out geometry. So what I'd like to do now is to integrate that into my asset, is this cutter. So to do that, I need to have it plugged into the asset. So I actually can't use this match size bit here. So I'm actually going to break that connection. And what we're going to do here on the line is actually just lift that up. And in the match size here, where it says justify center, let's set this to none. So we're just censoring it around the origin, but not affecting the Y here. So this will allow me to carry on moving that up and down independently. And because we're moving the door independently, a bit later on, you'll see that stays in position. So that we can just adjust the windows back using that. Because this all basically wants to plug into here. We could build all that inside, but I'm not going to. We'll let the user just create their own geometry out here and then plug it in. So how do we plug that in? We've only got one input here. So we need to make another input, and it's very easy. If you right click and bring up the type properties, what you can do is go to the basic here, and where it says maximum inputs of 1, set this to 2, and then hit apply. When you do that, you'll now have your second input here. We can now plug in our cutter geo to that. And if you hold your cursor here, you'll see it says cutter in. It remembered what we called it before. If we go here, you'll see it's automatically named it. That's because we named it on our subnet. If we hadn't, it would give some other name here, and you could just rename it yourself here. So we can easily add inputs later on by adding them here, maximum inputs. So minimum inputs just means the minimum that needs to be inserted before an error. So if I don't plug this in, I don't get an error. If I set this to minimum inputs of 2 and hit apply, I get an error because there's not 2 plugged in. If I do 1 and hit apply, there's no error because I've got this one plugged in, but if I disconnect it, there's an error, which is what you want. You want it to fail if nothing's plugged in. So I'll leave this at 1, 2 for now. This one's optional, so I don't want it to fail if you don't plug it in. You might want to cut things out, you might not. So let's plug in our optional one for the moment, and let's dive inside. So that's now coming in here in this second input, which is pretty handy. So what I want to do is actually cut out or Boolean that geometry from here. Now it's not a simple operation of just bringing in this geometry and just doing a straight Boolean, because it will give you errors. In fact, let me just show you. So if I hit tab and type Boolean subtract, let's bring this down here. Let me plug that in. Let me save just in case. Let's plug this in and we do a Boolean subtract. Oh, it won't work because these are packed primitives. So what we need to do is actually unpack it first. So let's run in and unpack. If we plug that in, it will take a second to unpack it, and then it will run the Boolean for us. And it might look all right, but there will be issues. This is not the best way to do it. What we really need to do is loop through each brick individually and Boolean them one at a time. And that will be a much more secure way of doing this. So this might take a while because we have quite a lot of bricks there. So what I might do is just pause the video while that does it. There we go, it's now done it. And as you can see, it's cut the holes and it looks like it's working. Now the first thing you'll notice, actually, we don't have a texture on these inner faces, but we do have UVs. That's because, actually, if you look at our cutter geometry, we added UVs, but we haven't added a texture. Those cutout holes inherit the attributes from the cutters themselves. So look, actually, let's just fix that quickly. If I just add a material to these boxes, let's just pop that in here, and we plug in our actual old brick material. Now if I go inside here and let it do the Boolean thing again, which will take a few seconds, so let me pause the video again. There we go. And we can see now that the textual information has appeared on those faces. But like I said, this is not the best method. If we add an exploded view node, this will actually separate the geometry out for us so you can see what we've got. And you'll see here, actually, it's first of all, it's not really working. So what we really need is to, when we unpack it, is to transfer that name attribute. so it comes through to the Boolean. That way we have all the separate chunks. So again, that's going to take a second or two to process, so I'll just pause the video again. Oh, that didn't have much of an effect, but you see the problem here anyway is the fact that these faces here are not joined to the rest of it. We get these horrible slithers. So we're not going to do it this way. Let me just come back to here so it's a bit quicker. So what we're going to do is we want to loop through each one of those bricks first of all. Now I don't want to loop through all of these. If you remember, if I just pop a null in, just so I can template my cutter, there we go. If you look, my cutter geometry is only really sort of in this area, so I only need to Boolean these bricks. So first of all, I'm going to just partition them so I don't have to Boolean all the bricks. So that'll be the first sort of speed saving we can do. And the second thing we can do is compile it as well, which will speed up our Boolean. And to make it accurate, we want to loop through each brick. So the first thing I'm going to do is create a bound node. What a bound node does, it creates a bounding box around your geometry. So here you'll see it's created a bounding box around my cutter geometry here. So I'm going to type 0.5 in all the padding here. This just allows you to change the shape of the bounding box. So look, now it's much bigger than everything. If I go into wireframe, you'll see it totally encapsulates it. So this is capturing definitely every brick that needs to be Booleaned. So there we go, that's the first bit. So the next bit is I want to, before I unpack these, actually, let's create a group. So to use, let's put the bounding box in the second input of the group here. So at the moment, this is still points effectively. So what I want to do in this group is call these keep me, because I want to keep the group. And I'm going to use the point mode. The reason I'm using the point mode, let me turn this off, is because when you do bounding box, you can only use another piece of geometry for points. So luckily, pack primitives are points, so we can get away with it. So if I do a bounding object, you'll see it's just selecting the objects within my bounding box. Now that's not displaying it at all correctly, which is a bit weird, but we can test that by using a split to be sure it's doing the right thing. So if I just split this into my keep me group, we'll see we're just keeping the ones within that bounding box. And if I just template my cutter, that's more than enough for the cutter. There's more than enough bricks in there. I'm not too bothered about the ones missing there. I suppose we could just maybe make the upper padding slightly bigger. There we go. Now we grab those ones in. So here I'm optimizing it. So I'm only really going to do a Boolean on just these few bricks in the middle there. And then we can merge everything together later on. So let's do that. Let's do a for each loop. And let's do a for each primitive again. So for each primitive. So the first thing I want to do is loop through each of these primitives. So in the split, that'll be the, let me just delete these guys, they're getting in the way. There we go. So that'll be this first input, that's just those few bricks here. And again, if we do a single condition, you'll see we're looping through each brick individually like that. And we only really want to Boolean the ones off here, actually. We could be more efficient, actually plug in the cutter geometry directly, but I think the bounding box is probably a little safer. But that's up to you if you want to do it. The few extra bricks I don't think will make that much difference. Let's turn that off. So the first thing we want to do is unpack. So let's unpack these bricks like that. And then if we hit W, oh, it's kept the shading there, but let's just bring the shot material path through anyway, just in case. And then what I want to do is then do my Boolean. So if I hit tab and type Boolean, we can use the subtract. Pop that in here. And then we can just plug in our, not the bound object, remember. So directly from the cutter. And there we go, that should cut our little bricks out. There's our little holes in the bricks. In fact, I'm going to use the null directly. And I'm going to call this cutter in. Oh, there we go. Let's just turn that off and on. And then what we want to do is just pack them up again back into their packed primitives. And then the pack, we want to just transfer any attributes back again. So we'll just put a star in both those bits. So any material attribute we unpacked will go back into the pack primitive there. So let's have a little look. And then we can turn on multi-threaded. And then you can hit escape to stop it doing that. And then you can do a compile block. And hit escape again to just jump around it. Escape again. Let's just turn that off and on to reevaluate. And you'll see that should be a lot faster. And again, it's given us that little error because this little block's not part of it. So we just make a copy of this, pop it over there. You'll see that's fine. But again, you'll see this branch doesn't come in our loop. So we have to make a copy of this top one, pop it in there, and set this to fetch input. So let's set that to fetch input. And there we go, all works again, and the compiled works. So you have to put the brown bubble again. Let me just do that again, just for sake of ease. So when you're making these compiled blocks, the first thing you want to do is just look at these inputs that are coming into the brown loop. We've got one here that doesn't have a brown node at the top. So we can just make a copy of this, set this to fetch input. That's because it's not doing anything. Just pop that over that branch. There we go. So now everything's inside this bubble. And then we can add the compile block over the top. So again, you want a yellow, that's all of these top ones over the inputs in. So there's two up there, and then this bottom one in the bottom there. And then that should all work for us. Don't know why it's still showing the errors. There we go. So now we have just cut out just the bit that we want. And then what we can do is add a merge. And merge it back to our split up here. So let me just bring these guys in a little. Let's just make this a bit neater. There we go. So we can take this and merge it with our split, and we have our big wall back again, which is really nice. So yeah, on this pack actually, we just we don't need to transfer all those attributes back, I think. Let me just do the material path. What do we have up here? So name, material path. So yeah, let's just make sure we have the same. So let's just pack the name as well. Doesn't really matter too much. And there we go. So we have our little cutout. Now there is some little problem, another little problem. If I go back to before the merge here, so we've got this little bit, and we actually have a look. If you think about it, let me go back to the for each here and turn on a single loop. So this is being Booleaned and being kept and so on. But then what we're dealing with is when we're dealing with the bricks actually inside these shapes. So that one's given us a half a brick. So 54 is actually inside there. But there's no primitive here because it's been totally removed. But if we look, we still get a primitive, even though there's nothing visibly here. If you look, if I unpack it, this single one here, you'll see there's no geometry. It's an empty primitive, which is bad. That's going to mess us up later. So when we've Boolean from an empty space, it's still kept the primitive for us. You know, here we've got no geometry, but this pack has still packed the zero geometry. So we don't want that. We want here, when we've got zero geometry, we don't want to pack it. So I'm just going to add a little switch node here. So we bypass, we don't pack when here is zero. When there's no points, we don't want to pack it. So I'm going to create a switch. And if you look, we've got, if I turn off this, actually, you'll see how many pack primitives we've got. We've got 912. But we don't want these empty ones in these empty gaps. So let's add a switch. I'm going to add a null. So when this is 0, it's going to ignore this branch. It's not going to pack it. It's just going to do nothing. So we'll end up with no packed geometry here. If I look at the null, we end up with nothing packed. Okay, and then in here, what we're going to do, again, we need our spare input. So click on here and choose spare input, otherwise it won't compile. There's our spare input. And we're going to drag in that Boolean node to the spare input, because we're going to read this geometry. I basically want to say when there's 0 points, switch. So in the select input here, I'm going to type this expression. Let me just make this big. So expression, edit expression. We're going to use the endpoints expression. So it goes like this, endpoints. And then endpoint says, just give me a node and I'll tell you how many points are in there. So I'm going to do -1, which is the Boolean node. I'm going to say when that equals 0. So when the number of points is 0 is true, we're going to switch to the null. Let me hit apply. Okay. Now it looks like nothing's changed, but now we've only got 700 instead of 900. And if we look now on our switch, it's still switching, but we're not packing this time. You'll notice that's grayed out because the last one must have been cut off. So now we don't have our 0 ones here. If we go back to our single loop, hang on, maybe I should turn that one. If we go back to the single loop here and look at number 54, you'll see there's no primitives. There's nothing packed. So we have no packed primitives there. So that's important that we do that so we don't end up with these 0 packed geometry, because that's going to mess up stuff later on. So now we've only got 700 primitives instead of 900 odd. And there we go. There we've got our full wall again. So the last thing I actually want to do is then create a group for it all. So let's create group. I'll merge stuff here, and we'll keep the primitives. Let's call this wall GP, wall group. So we know we've got access to those individually. So let's now finally pop this, complete this in our asset. So my asset here, basically, let's turn off this unpack, is outputting through this output node. So whatever that output node is connected is what the asset outputs. As you can see here, we've got one noggin. So what I'm actually going to do is create a second output node. And interestingly, if you color them, let me color this one green and this one red. Let's call this output wall, and we'll call this output wall cutout. So one, let's plug this into the group here. And let's plug this one over there. So this one is also called wall group, it doesn't matter. So here on one output we've got the wall, and the other one we've got the cutout. So if we go up here, you'll notice it's giving us an error because we've only got one output. If we right click and go to type properties, we also need to say maximum outputs here too, to allow for that second output. So if you hit apply now, your error should go away. Oh, okay. The other thing you need to do here is the index. Index 0, this one also said index 0. Let's set this to index 1 so it knows which output to connect to. Let's see if that works. There we go. So they have to have a unique index. This refers to the first output. This refers to the second output, 0, 1. So if I go up now, there we go. So this is number 0, and you'll see it says output 1, and this is output 2. Now if we go to the type properties, we can go to the input outputs, and we can give them labels here as well. So we can call this wall, and we can call this wall cut out. Apply, accept, and now they have those names. So there's wall, and that says wall cut out. So if I add a null, I can access my wall, or if I look at the other one, that's the cutout version. So we've got the cutout part of it there, and we've got our group naturally attached to it. In fact, let's call this, instead of wall group, wall cut group, so we know the difference. Excellent. So there, we've kind of finished our digital asset for the moment. So what I'd like to do now is start to lay this out to build the scene, and then build the other details that we need, which is the window frames, the door, the glass, and some water as well. So we'll look at that in the next video. Thank you.